Okay, welcome to this channel. If you are new to this channel, make sure you subscribe, to like and share. Now today we shall be talking about integration by substitution. Now anytime you see an integration like this having a power, actually you may say you want to expand it, no problem, but at times you may have a power that you cannot expand. So what do? You can do substitution method. And how do you do it? Now whatever that you see like this in the bracket, we represent it by with u equals to s squared plus 1. After that, you find the u dx. And why are we doing this? You want to find the x. Now you find the u dx. Our du dx equals to, what's the du dx of s squared? That is 2x. And this one is 0. That means, so we are finding dx, don't forget. That means our du equals to 2x when you cross multiply. 2x dx. That means all over 2x. All over 2x. That means our dx equals to du all over 2x. That means I've gotten my dx. So what will I do now? That means I will now do, I have integral of, don't forget, x. I've represented this one to be u. That means multiply by u raised to power 2 multiply by, what is my ds? My ds is du all over 2x. That means this x can cancel this x initially. That means we have, what we have left now is integral upper limit 1, 0, and we have u squared du all over 2. Du all over 2. So what will I do? You know that this one is 1 all over 2, so you can bring it out. That means 1 all over 2 integral of upper limit and 0. So we have u squared du. So you will now find the integration of u squared. When you find the integration of u squared, so that will be u 2 plus 1 all over 2 plus 1. But do not forget this, that is 1 all over 2. So definitely you have 1 all over 2 integral, that is u raised to power 3 all over 3. Now after that, what will we now do? We are having 1 times u cube, that is u cube, all over 2 times 3, that is 6. 6 plus x. But anytime you are given upper limit and the lower limit, so we have to substitute for the both. And how do we do that? Now this result you got, open 2 brackets for them. U cube all over 6 plus x minus u cube all over 6 plus x. But mind you, in this u, you cannot just write your answer like this. Substitute the value back. The value given to us back for this u. And what is the value? The value given to us, it is s squared plus 1. That means s squared plus 1. Because this is our u. Raised to power 3 all over 6 plus x. That means I'm going to substitute it back here for this. That means we have, for this u now we have s squared plus 1 and s squared plus 1 all cubed. Now when I have upper limit of 1, I'll substitute everywhere I see x. I'm going to substitute it here. That means I see x here, that is 1. That means 1 raised to power 2, 1, and 1 plus 1, that is 2. 2 raised to power 3 all over x plus, I have 1 here, 1 minus, if I put the lower limit is 0, I'll substitute that 0 here. If I put 0 here, 0 raised to power 2, that is 0. 0 plus 1, that is 1. 1 raised to power 3, that is 3. All over 6 plus 0. That means I'm having, I'm going to have 2 raised to power 3, that is 8. 8 all over 6 plus 1 all over 1 minus, I say 3 here 1, 3 here 2. 1 all over 2, you know, plus 0 is still 1 over 2. If you find the LCM for this, you are having 6. 6 in 6, that is 1. 1 times 8, that is 8 plus 6 in 1, that is 6. 6 times 1, that is 6. It will give me 8 plus 8, that is 14 all over 6 minus 1 all over 2. So we are having, what's LCM? Our LCM is 6. 6 in 6 is 1. 1 times 14. 14 minus 6 in 2, that is 3. 3 times 1, 3. 14 minus 3, that is 11 all over 6. That is our final answer. Now let's take like 2 more under the substitution. Now what if we have something like this? Integral of sine cube x all over cos square x dx. We have something like this. What we are going to do is that anytime integral come like this, we can just represent the denominator with u, because we are looking for dx. That means our u equals to cos x. When our u equals to cos x, we find the u dx. And what is the u dx of cos x? That is minus sin x. And don't forget, I'm actually looking for dx. That means du equals to minus sin x dx. So I'll divide both sides by minus sin x. All over minus sin x. All over minus sin x. That means my dx equals to du all over minus sin x. We can now reframe it. We have sine cube x all over, I've represented this one by u. That means u squared multiplied by, what's our ds? Our ds is now, our dx is now u all over minus sine x. Now when I have this can cancel this, so we are going to be left with 2. That means integral of sine square x all over u squared multiplied by du. Multiplied by du. Now, when we have this, we know in our trig identity, that sine square x equals to 1 minus cos square x. We know this, that sine square x is 1 minus cos square x. So that means I can just say sine square x is 1 minus cos square x all over u square multiplied by du. Now, what will I do? Do not forget that my u, I represented u by cos x. That means I can change this cos square x to u. That will be because it is represented by u from the start. That means 1 minus u square all over u square multiplied by du. Now, what to do? That means if we have to now integrate what we see there. If I want to integrate 1 minus u square all over u square du, I can just distribute this one under each. I'll just say this one divided by this one divided by, that means 1 all over u square minus u square all over u square. So that means this one will be, if I bring this one up, according to law of indices, u raised to power minus 2, and this one is 1 du. That means I will integrate this and I will integrate the 1. How will I do that? If I integrate u raised to power minus 2, that will be u raised to power minus 2 plus 1 all over minus 2 plus 1. And integration of 1 can just be u. Integration of 1. So because we are following u not x, so it can just be u. That means if I integrate this now, that is u minus 2 plus 1, that is minus 1 all over minus 1. And minus, because this one, there's a minus here. That is minus integration of 1, that is, let me call it u. Let me use the letter u because we are referring to the letter u. So that means this will be minus u, because this minus can come up here. Minus u raised to power minus 1 minus u. So lastly, I can just say, if I apply the law of indices, negative index, that will be minus 1 all over u minus u. Plus c. Plus c. So we can now substitute back in our answer for u. Our answer is minus 1 all over u minus u plus c. Now, what is the u initially? U is cos x. That's 1 minus cos x minus cos x plus c. So, that is that abala. Let's pick one more for the integration by substitution. Okay. Let me pick one more. Find the evaluate the integral. They are given something like this. Pi all over 4 and pi all over 12. 2 cos 2x dx. Now, if we are given something like this, 2 cos 2x dx, how do we go about it? Now, just represent your u to be 2x. This 2x. Find the u dx. Du dx is 2. Don't forget that our target is to find this dx. That means du equals to 2 dx. So if I divide both sides by 2, because I'm looking for dx, that means my dx is du all over 2. Now that I've gotten my dx, if I come back to this integral, pi over 4, pi over 12, 2 cos, this one is represented by u, 2 cos u multiplied by, what is my guess? My guess is du all over 2. Du all over 2. That means these two cancel these two. If these two cancel these two, so we are having the integral. And what is integral of cos u? What is integration of cos? So integration of cos is sine. So that means integral of cos u is going to give me sine u. Going to give me sine u. We are going to neglect this du plus c. Sine u plus c. Now, are we going to stop there? No. We substitute the value of u. And what is my u? Our u is 2x. That means sine 2x plus c. But do not forget, you cannot stop here because of this upper limit and the lower limit. We are given the upper limit and the lower limit. Now, what do we do about the upper limit and the lower limit? Now, the upper limit given to us is pi all over 4. What is pi all over 4? Pi is 180 all over 4. And what is that? Is 4 in 18. That's 4. That's 460 remainder 2. 4 in 20. That is 5. That means pi all over 4 is 45. And we're also given pi all over 12. That is 180 all over 12. And say 6 here 30. 6 here 2. That is 2. That is 15. So according to what we did the other time, that means our upper limit is 45, our lower limit is 15. So what we will now do is that we just bring our answer, we open 2 brackets. That means sine 2x, open bracket, minus another sine 2x. Another sine 2x. That means sine, first bracket, sine 2, open bracket. What's my first upper limit? That's 45. Minus sine 2, open bracket. What's my lower limit? 15. So we are having sine 90. 2 times 45, that is 90. Minus sine 2 times 50, that is 30. Sine 30. Now, sine 90. We check your calculator. You know, sine 0 is 0, while sine 90 is 1. And sine 30 is 1 all over 2, which is 1.5. So I can just say all over 1. So find the LCM. 2. 2 in 1, 2. 2 times 1, that is 2. Minus 2 into 1, 1 times 1, 1. So 2 minus 1, that is 1 all over 2. So the answer for this is 1 all over 2. 1 all over 2. Okay? I would like us to have a good knowledge of this called substitution. Now, if you are having integral of cos 5 raised to power x and sine x dx, I think if I do this one, we should have gotten a good knowledge of by substitution. I don't see anything that is special here anymore. Now, if you are given something like this, how do you do it? Just represent cos x by u. Let's say u equals to cos x. Don't forget you are looking for dx. That means du dx equals to, what is du dx of cos x minus sin x? So just say du equals to minus sin x dx. So you divide both sides by minus sin x because you are looking for dx. That means our dx equals to du all over minus sin x. Du all over minus sin x. Now, if you have gotten that, what do you do? Come back here to our integral. That will be we have represented this one by u. That is u raised to power 5 multiplied by sin x multiplied by, what's our ds? Our ds is du all over minus sin x. Du all over minus sin x. That means this cancels this. This cancels this. So we are left with, what is integration of u raised to power 5? Do not forget this minus. It will come and reflect back here. Du. So that means, because this one is 1 and the minus comes back here. So that means integration of this, that is 6, no plus 1, all over 6 again. So that means our answer. And what's our u? Our u is actually cos x. That means minus cos x. Yes, cos x. I just said all over 6 plus arbitrary constant, that is arbitrary constant, that is C. So this is all about it. This is all about it by substitution. Okay, let us go to another aspect. We are having an integration like this.
Because that's issue, because of this one. There is not.
Now, if you are dealing with integrations like this, you are having some. Now, we are still on integration by substitutions. Now, when we have questions like this under integration by substitution, now let's take a look at that number 1. That number 1 says x exponential x raised to power 2 dx. How are we going to solve something like this? This x squared that is here can represent it by u. Say u equals to x squared. U equals to x squared. After that, don't forget our aim is to find this dx. That means du dx equals to 2x. And that means our du equals to, when you cross multiply, 2x dx. All over 2x, all over 2x. 2x cancel 2x. That means our dx equals to du all over 2x. Now that I've gotten my dx, all I do, that is integral of x exponential x raised to power 2. And do not forget that this one has been represented by u. U multiplied by, and what is our dx? Our dx is du all over 2x. Du all over 2x. Du all over 2x. So what are we going to do? This x cancel this x. So that means we have integral of exponential u du. Now, if you want to find the integration of exponential x, it's still going to give you exponential x. That means integration of exponential u is still going to give me exponential u. Exponential u plus c, arbitrary constant. But do not stop there. Do not stop there. Because we have to substitute for the u. And what is your u? Our u is s raised to power 2 plus c. So that is number 1. Now let's take a look at number 2. If you look at number 2, we are given integration of s squared plus s dx. Here we are going to represent this one by u. U equals to st. Our du dx, that will be 3s squared. We are going to use this power to multiply this, and we remove 1 from the power. So that means our du equals to, we cross multiply, 3s squared dx. 3s squared dx. That means we are looking for dx. It said all over 3s squared. All over 3s squared. This cancels this. That means our dx equals to du all over 3s squared. Do not forget that I'm looking for dx. So that means if you become s squared multiplied by and cos, this one has been represented by u, cos u multiplied by, what's my ds? My ds is now du all over 3s squared. Let me, this will cancel this. So that means this 3 can come from 1 over 3. 1 all over 3 cos u du. 1 over 3 cos. That means it will not be 1 all over 3. If I integrate cos u, what will be integration of cos u? Cos that will be sin u. So that means my answer will be 1 over 3 sine. And what is my u? My u is st. s cubed plus c. This c is our arbitrary constant. Now let's go to number 3. Now for number 3, we are having integral of s squared, open bracket 3 plus s cubed dx. Now, how do we solve this? Like I said earlier, because this one is in the bracket, we represent here with u. That means u equals to 3 plus s cubed. Now find the u dx. When you find the u dx for this, you know that integration of 3 is 0. So 3s cubed is going to give me 3s squared. 3s squared. So I will say the u equals, if I cross multiply, 3s squared dx. So I will find, I'm looking for dx. That is all over 3s squared. S equals to u all over 3s squared. Now I have gotten my dx. That means I'm having the integral of s squared. This is u. I've represented this one by u. U raised to power. And what is my ds? My ds is now u all over 3s squared. This stands for this. So I will now integrate this. I'll bring this one over 3 outside. 3 over 2 plus 1 over 1 all over 3 over 2 plus 1 all over 1. So that will be 1 over 3 to bracket u. My epsilon is 2. 2 into 1, 1 and 3 plus. Okay. I've brought this 1 over 3 out here. So I have to integrate this u raised to power 3 all over 2. And what do? That's plus 1 all over 1. And what you have here is what you are going to bring down. So that is how you find the LCM for this. That is our 3, 2 into that is 1 times 3, and that's 2. So we're going to have the same thing here, 3 plus 2 all over 2. Now the u. So what do we do? We're going to have we are going to have 1 all over 3 into bracket u raised to power 5 all over 2 or 5 all over 2. So that means 1 all over 3, that is u raised to power 5 all over 2 divided by 5 all over 2. You are having 1 all over 3, u raised to power 5 all over 2 times 2 all over 5. Actually, it will give us 1 all over 3 open bracket 2u all over 5. So finally, we're going to have 1 times this, that is 2u raised to power 5 all over 2, all 3 times 5, that is 15, plus arbitrary constants. And we know our u, that is 2 open bracket, our u is 3 plus x raised to power 3, power 5 all over 2, all over 15 plus c. Now lastly, number 4. Number 4, we are having integral of x root 1 plus s squared dx. So what do? We're going to represent what is in the square root by u. In order to get our dx, that means u equals to 1 plus x squared. We are looking for the u dx. What is 1? 0. Integral of division of x squared, that is 2x. So I will do du equals to, if I cross multiply, 2x dx. So that means all over 2x, all over 2x. The x equals to du all over 2x. Now that I've known the x to be du all over 2x, that means integral of x root. Now this is u now. I've represented this one by u, multiply by, and my dx is du all over 2x. So that shows that my x here can cancel this. And I can bring this 1 over 2 outside. That is 1 over 2 integral of root u du. Now that means you are going to have 1 all over u. This one can turn to, our root can become 1 over 2 plus 1 all over 1. All over 1 all over 2 plus 1 all over 1. What you have here, you bring it down. That is 1 all over u to u. You find the LCM. That is 1 plus. Between 1 that is 2. There is 1 that is 2. No, that is 3 all over 2. But this will give me 3 all over 2. And this is the same thing I have to do down. So I have between 1 all over 2 into u raised to power 3 all over 2 all over 3 all over 2. So we have 1 all over 2. We should have known what it will give us. That will be 2u is power 3 all over 2 all over 3. And if you are having 1 times 2u, that is 2u power 3 all over 2 times 3, that is 6 plus c, arbitrary constant. And this one 1, 3. That means you are having u raised to power 3 all over 2 plus constant. And what's our u initially? Our u is 1 plus x squared. 1 plus x squared plus arbitrary constant. So the special substitution that we can have